In this series of videos, we're going to look at how different types of matter can be classified based on two different criteria. The first of which is we can classify different types of matter based on the number of elements that are contained within the substance. And the second way, which is actually going to be the series of videos following this, is we can classify matter based on the different properties that a given substance has. That being, what does the substance look like in terms of its appearance, and how does the substance behave when it is mixed with other substances. Now, if we are to classify different types of matter, the first classification, or the first criteria that we look at in terms of grouping types of matter into one group or another group, is looking at whether matter is an example of what we call a pure substance. So in chemistry, the word pure simply means that when we have one type of matter, we are looking at only that one type of matter and not a mix of different types. So that's what pure substances are, and we can take a very obvious example of a pure substance versus something that is not pure, what we call a mixture. So in this glass, we can see that there is a transparent, colorless liquid. What we are doing there when we say transparent, colorless, and liquid is we are describing the properties of what we see here, and more detail will be explored in following video series about properties. Now, if you were to guess, most of you would probably guess that this clear, colorless liquid is water, and if we were right, we can say that water has a specific chemical formula, that being, if we take two hydrogen atoms and one oxygen atom, we can put these together in order to make one unit of water. And if this glass of water had only water in it, it would be considered pure. However, if we take a glass of water and if we add this white crystalline solid powder into it, and if we were to say that the two atoms that we put together to make this white crystalline powder are sodium and chlorine, we could conclude that this white crystalline powder is actually plain old ordinary table salt. However, if we were to take this salt and drop it into a glass of water, we would not have a pure substance anymore, because we would have salt water, or rather, if we use the formal term for this, we would have what we call a mixture of salt and water. More on that in the next video. So now that we can tell the difference between a pure substance and a mixture, the next thing that we need to do is describe the difference in classification between the two types of pure substances, the first of which we know as elements. And we don't really need to spend too much time on what an element is. As a quick review, it is any type of matter that cannot be broken apart or broken down into smaller substances, because each element only contains one type of atom. And you can identify whether a substance is an element or not simply by looking at the periodic table, which is what we've been doing over the previous 3 video series. Nevertheless, if we do some quick review, we can see a few examples of elements here. For example, these metallic nails are actually made of iron, which is a very useful element for human technology, because our ability to melt down iron and shape it into different shapes, depending on what we need, has allowed humans to make different tools as well as weapons out of iron. This bright, shiny, yellowish metal, which is actually quite flexible and also very heavy, is another example of an element that we call gold. So gold obviously is very expensive because we use gold for currency, but we also have a number of other useful applications of gold, such as in rust proofing, because gold doesn't react very well with oxygen in the air. Now, if you correctly identified this, you would have said that this is indeed a diamond, which is exactly what it looks like here. Now, the interesting features about diamonds is that they are actually made of a very common element, that being carbon, which is actually the same element that most of our body, or at least the solid mass of the body, is made of as well. And if we think of the gases in the Earth, which is what we call the Earth's atmosphere, a lot of the most important gases are examples of elements as well. For example, the oxygen that we breathe and the nitrogen that colors the sky blue when light from the sun hits it are examples of elements that we find in the atmosphere as well. However, you'll notice that water is not classified as an element because what we call the chemical formula of water actually shows that it is made of multiple elements put together. Now, substances like this that are made of multiple elements are simply what we call compounds. So we can see by looking at the types of atoms that water is made of that water is a compound rather than an element. So again, compounds simply contain multiple elements, and you can fix this right on the handout here. Now, if you were a little bit apprehensive about looking at a substance and immediately being able to tell what types of atoms you find within that substance, you would be right. This is not something that anyone can do. Instead, what we can do to identify a substance as being a pure element or a compound is to look at what we call the chemical formula. This is a word or a term that I've been mentioning throughout the video, and the chemical formula is simply a list of which elements and how many of each element we need in order to make that compound. For example, this white crystalline powder is table salt, which we can make by combining atoms of sodium and chlorine together. Now, these two, firstly, this white crystalline powder here, if you recognize this as sugar, sugar actually has a relatively complex chemical formula in that it's made of 3 elements, carbon, hydrogen, and oxygen, and we need 6 carbon and oxygen and 12 hydrogen in order to make a single unit of sugar. Now, not all compounds need to be solid. For example, water is a liquid. Another example of a liquid compound is vinegar, which has a rather interesting chemical formula as well that we write like this. So we can see that carbon, hydrogen, and oxygen combine together to make vinegar, but depending on the number of each atom and the arrangement of each atom, we can see that we can get very different compounds here. Finally, if we return to Earth's atmosphere, we can see that there are examples of compounds in the atmosphere as well. For example, if we look at the clouds that we can clearly see, well, clouds we know are made of water. This is where our rain comes from. So this goes to show that not all water is in the liquid form. Some of it exists in gas form up in the atmosphere. And another famous example of a compound that we find in the atmosphere that's responsible for keeping the Earth warm, but also responsible for a lot of the pollution that we have, is carbon dioxide. And we can see from the chemical formulas H2O and CO2 that it isn't a single element that makes up these substances. Therefore, carbon dioxide and water are examples of compounds rather than elements. In the next video in this series, we're going to take a more detailed look at compounds specifically and looking at how we can further classify compounds in more detail based on the type of elements that are required in order to produce these specific compounds.